Okay, it's the Unknown Mechanic back, and this channel is for the shop owner who doesn't have technicians that are up to par and are always fumbling and bumbling their way through jobs and unsuccessful in completing them. And it's also for the aspiring mechanic who wants to raise their level and not have to go ask their boss stupid questions every 5 minutes and successfully complete a job on their own. And it's also for the do-it-yourselfer homeowner who may want to learn how to diagnose and troubleshoot and then repair on your own. So today we are working on a Stihl 025 18-inch chainsaw. It's a late 90s or 2000 vintage, and it belongs to Smelly Butt Trash, or no, excuse me, Smelly Butt Lash. And it says, won't start, and how dare you operate chainsaws on stolen land. Repairs necessary. Well, don't really know what to make out of that. A lot of times I just ignore what the customers say, and you have to make your own decisions and your own evaluation and proceed forward. Now, this saw has already been worked on, and I've had a lot of crappy mechanics that work for me. We had going way back, Secret Agent Man, and The Big Asset, and Gomer, and Sniffles, and Scratch, and Dingus, and Einstein, and I think Einstein tried to fix this, and he's put some parts in it. Looks like he's got a fuel line and a fuel filter and a carburetor repair kit. And he says, cannot adjust. So he gave up on it. And so now it's dumped in my lap and I have to fix it. So one of the first things you want to do is you want to revisit everything that either the customer tried to do on their own or your crappy, shitty mechanic did. You have to recheck all of that work. So I see that there's a bag of used parts here. And okay, there's a fuel hose and a fuel filter and a carburetor overhaul kit. That's what's in it. And so first thing I want to do is a visual inspection, and then I want to check the work that's been done. One thing that I can do right away is I could pressure test this fuel line. And now that it's out of the saw, that's going to be very simple. You can just connect your tester there. Actually, one little tip I want to give you is before you pressure test anything, you always want to very quickly test your pressure tester. You see, that's holding pressure. It's almost 1 bar. It's probably about 10 pounds. And the reason why you do that is because there could be a small hole in your actual test hose here. So you definitely want to make sure that you're airtight up to where you're connecting. One time, Secret Agent Man, he worked on I think it was an Echo line trimmer for a whole day and could not get the carburetor to hold pressure and the fuel line to hold pressure, and he gave up on it, and he asked me to look at it, and he had a pinhole in his pressure tester hose. And so, he was getting a false leak because it wasn't leaking from the carburetor or his fuel line. It was actually leaking from his tester line. So you verify your tester first, which I've done. Then you can connect, and you can plug off the other end, and it is holding. So this line is not bad, but being that this saw is 25 years old, maybe older, this looks original to me, and they do rot. And right here at this pleated area on the external part, they can crack and you'll get a leak. And so it's not a bad idea to replace a 25-year-old fuel line. But this one does hold pressure. Same thing with the fuel filter. These are so inexpensive, and it's not going to cost a lot to just put a new one in to eliminate any question. And if this saw, again, is 25 plus years old, this may be original, and dozens and dozens of gallons of fuel may have passed through that filter, and it's could be partially blocked. Now, looking at the carburetor parts that he's put in here, this is the correct kit. This is an OEM Walbro K10WAT, and they give you a lot of extra parts to service all different types of WA and WT carburetors that you don't need. So there's lots of leftovers. But I can see that the metering diaphragm, you can hear it. It's very crinkly and crispy. When it makes that sound, it's gone. It needs replacement. The convolution in the diaphragm is not flexible enough to allow the diaphragm to meter the fuel. So definitely needed a carburetor overhaul. So I don't see anything super wrong here at the moment. So we're just going to take some things apart and take a look. All right, first thing I see is that the air filter is not installed correctly. It's only halfway on. It should be seated fully like that, so it's airtight all the way around. That's a mistake. This is also the screen mesh type instead of the felt type. And the screen mesh is less restrictive and can potentially give you higher horsepower, but a very, very, very fine abrasive dirt can pass through the mesh style air filter and wear the engine out faster. I generally prefer to use the felt filter for here. Not 100% clean either. He should have cleaned that. Let's see. Take a look at the spark plug. Okay, this is a Champion RCJ6Y. Maybe way back in the day, Stihl did use some Champion plugs. It looks very, very oily. It's supposed to be more of a brownish tan if it were burning correctly, probably going to replace that. It does have a solid top, that's important. Stihl does require a non-removable terminal, a solid terminal. That's very important. And let's take a look here. I'm going to revisit his carburetor overhaul just to see if he did anything wrong in there. Okay, now the choke can be disconnected by, let's see, putting it in the choke position. And then the link will pass through the choke arm. So you don't ever want to bend these choke links to remove and replace them. There's always a way you can maneuver the choke and the master control lever to get that out without bending. And we are going to drain the fuel. There's fuel in it. And this is probably not the customer's fuel. This is probably already our shop fuel. And that fuel looks 100% clean, smells fresh. That's our shop fuel. No dirt. That's fine, nothing wrong there. And I like these tools for removing the fuel line. Very handy. Now the throttle linkage can be disconnected by prying up here. It snaps into place. There. It can be rotated and unhooked. Again, you do not have to bend any linkage to remove and replace. And now the carburetor should come off. Fuel line slightly in the way. Okay, that gasket is supposed to be there, and it looks fine. And it is going to be drawing impulse through that hole. So, you know, there's an impulse hole on the carburetor body right there that mates up with that, and that is then routed to the fuel pump. So positive and negative pulses from the lower part of the engine are directed to the pump and operate the fuel pump. All right, so one of the first things I see, you know, the comment on the tag from Einstein says cannot adjust. Well, this vintage of 025, the high speed is fixed. It is not adjustable. Only the low speed mixture and the idle speed are adjustable. So you can't adjust it because it's not adjustable. It's a fixed jet. So I don't really know what to make of that. Then when you take these carburetors apart, many of them, like the Walbros for example, there is a small dot on the head of the screw. And that dot next to the cross, the Phillips, would indicate that it's a JIS, Japanese Industrial Standard screw. And so you have to have a JIS screwdriver. They fit much, much better in this type of a screw than an American Phillips. And same thing for the pump cover. I see that the pump cover doesn't have a dot next to it, but you can put American Phillips in here and feel for sloppiness, and then you can put your JIS screwdriver in here, and whichever one fits better, that's what you're going to use. Okay, that was good and tight. And this is dry as a bone. There is not one drop of fuel in the pump. You know, the diaphragm, the fuel pump diaphragm is in there correctly. The fuel pump diaphragm goes against the carburetor body first, and then the gasket, and then the pump cover. And everything looks good here. I don't see a problem. And I'm taking note of which way the atmospheric vent is located. It is pointing away from the engine and towards the air cleaner, so I'm going to put it on the same way when I go back together. I just want to see if there's any mistakes in here. Yep, looks brand new. Now this one, much more flexible. It does not make that crinkling sound like this old one. Okay, and the metering chamber, just like the pump, is dry as a bone. It's like Death Valley in there. There's zero fuel in there at all. And this is the high-speed jet. These are numbered, and there's no adjustability at all in the high-speed mixture of this carburetor. Sometimes the semi-fixed or fixed jet carburetors have an advantage over a fully adjustable carburetor in that the jet in an adjustable carburetor, the tip of the needle extends into the center of the jet. And if you were to use very low octane fuel like 87, Stihl recommends 89 or higher, but you know, you get some cheap people that just buy the cheapest gas, and then if you were operating the chainsaw in 100-degree weather, very hot weather, with low octane fuel, just at the point where the fuel is beginning to boil, small air bubbles are more easily caught in a needle valve jet as opposed to a fixed jet. The fixed jet, the hole is round and wide open, and little air bubbles will pass right through it. Now it appears as though the low speed may be a fixed jet as well, because I see another jet over here with a very tiny hole in it. So if this low speed screw is closed off or somebody tries to lean it, some of the fuel can bypass this adjustment and get into the low speed circuit through this jet. Now it looks like the metering lever is set too high. I want to check that. That could be an error. So I don't have my my Walbro W gauge with me, so I'm going to pause the camera and I'm going to go get that gauge, and we're going to measure that metering lever height. Be back in a second. Okay, I'm back with my metering lever gauge collection. Got two Walbro gauges here, W gauges. One is of a newer vintage. I don't need the new one. I use the old one for, this is a WT. So we'll get that off. And we'll just put that on there and see what that looks like. Yeah, it's definitely high. Very high. Okay, maybe I can bring the camera in for a close-up and you can get a better look at it. All right. See, they're definitely too high. So, I'm going to make some adjustments. And I also, I've got my shop microscope here, and I was able to, put this underneath the mic and focus in, and I've checked the high-speed jet. It's numbered 57. And then this low-speed jet over here, which is numbered 30. And this looks like this is a dependent circuit carburetor. And that would mean that the low-speed circuit does not pick up its all of its fuel from the metering chamber. It could pick up its fuel from a cross-drilled passage leading to the high-speed circuit. Or it could be an independent circuit carburetor in that it picks up all of its fuel from this low-speed jet, and somehow that passage is routed around to the adjustment needle, and then the adjusted amount of fuel is then routed to the low-speed circuit, which is under the Welsh plug. There's a primary idle hole, and then there's some progression holes for acceleration and part throttle operation. So I'm not too concerned about positively identifying what type of carburetor this is. I've had this under the mic, and this 30 jet and this 57 jet are 100% wide open and clean. I don't see anything in them at all. And so what I'm going to do is I've noticed that Einstein, he selected a K10 WAT repair kit, and that's actually the wrong kit. Okay, this WT carburetor calls out for a K20 WAT, and the main difference between a K10 and a K20 kit is the size of the needle. The K10 kit is supplied with the earlier large needle, and the K20 kit I believe is supplied with both the old large needle and the newer style small needle. And this carburetor definitely has the small needle in it. And once again, I see that the screw that holds the metering lever fulcrum pin in place has a small dot near the cross. And so I am going to be using this JIS number 2 driver. This is a vessel. It's made in Japan. I got this from Echo, but you can get these also from Amazon. And that's the screwdriver that fits this perfectly. And I don't have to take this screw all the way out. It can just be loosened. And then the fulcrum lever and pin and metering spring will come out. And you got to be careful not to lose these. Very, very small parts. And I see that the needle is in there. And you can see the difference in size from the newer style needle and the original needle in the earlier carburetors. Now, since this is the wrong kit and the small needle is not supplied in the wrong kit, I'm going to be reusing this needle and checking for leaks. But I did notice that I don't think that he has replaced the metering lever and fulcrum pin. And if I install this new one out of the kit, I may not need to bend the lever at all. This lever is possibly the same or possibly the right level as the one that's set too high. So these are difficult to get in. Oh, another thing I see in this carburetor that's an advancement that I should mention is down in the needle bore. This is not an aluminum seat. What's down in the bottom there is a nickel-plated brass seat, and that's common to the more modern carburetors, and that type of seat is very reliable, very corrosion resistant, very long life. And that brings up another point. Einstein, he's the mechanic that worked on this, and he will do anything to avoid a carburetor overhaul. He just immediately will jump right into replace the carburetor. No carburetor overhauls. And that's because his carburetor overhauls are so bad that he has, less than a 50% success rate if you were to clean a carburetor. And I always laugh, when somebody's track record is so hit and miss that they don't even try. And the reason why he could not replace the carburetor on this is because it's no longer available. You cannot get this carburetor from Stihl. It's obsolete. And that means that you have to repair it. And when Einstein is in a situation like that, he's got a 50% failure rate. One of my other crappy mechanics, Speedy, he just loves to do carburetor overhauls. But Speedy, he's obsessed with the sonic cleaner. And the sonic cleaner works very well for 4-cycle float lawn and garden carburetors. But in 2-cycle carburation and a chainsaw application where the fuel is down in the tank and pickling and deteriorating, decomposing, and the fuel that remains inside the carburetor, it evaporates. And most of it is gone, and there's a protective film of premium 2-cycle oil inside the fuel pump area and the metering chamber area, and that preserves the carburetor. And really, you don't really need to clean like water damage and old fuel that will collect in a float carburetor and degrade. And so, but Speedy, he won't even diagnose a machine. He will immediately take the carburetor off, take it apart, put it in the sonic cleaner, and let it buzz for 30 minutes. And a lot of times he won't even disassemble them to this state. He will put them in more whole, and he expects the sonic cleaner to magically remove all the dirt out of the inside of the carburetor. And his carburetor overhauls are so also very hit and miss. He will take a clean carburetor and he will never change the solution in the sonic cleaner. And he'll take a clean carburetor like this one and put it in polluted, dirty solution and contaminate a clean carburetor. And a lot of his carburetor overhauls would go out, and then a week or 2 weeks later they would come back and there would be fuel pouring out of the air cleaner, fuel collecting in the bottom of the engine, filling up the crankcase, and you connect your leak detector to his carburetor overhauls that were done a week or two prior, and they leak. And there's always some kind of dirt contamination that made its way beyond all of the fuel filters, and particularly the secondary filter, and get caught between the needle and seat. And so, Speedy, we caught him doing loads of laundry in the sonic cleaner. And at one time, we caught him sitting on the sonic cleaner like the pot. He was trying to clean the barnacles off of his bean bag. And you can't overuse the sonic cleaner. It's not the magic fix-all for a shitty mechanic. Okay? So, anyway, we're going to put this back in. I'm going to drop that needle in there. And these are very, very tiny parts, very hard to work with. The spring looks like nobody's tampered with it. And we're going to use the new fulcrum lever and pin. And very carefully try to maneuver this in here. Just hold it in place and then tighten up your screw. And it's definitely in place. The spring is captured onto this dimple, and it's seated in the hole in the floor in the metering chamber. And my fulcrum lever is engaged into the captive needle, and I'm going to tighten the screw. And this, by eyeball, my eyes aren't that good, but this one is lower than that one. And oh, that looks really good. Now, Walbro describes in their service manuals as the tip of the W. And you see that this point in the center of the W is marked WTA, WA, and WT. So we are going to be using this side of the gauge, and it describes it as touching with a very slight drag when you move that across. And if your eyesight is not that good, like mine, I need glasses, what you can do to be accurate and not rely on your eyesight is you can reassemble the pump side of the carburetor. That's another thing I'm going to do here is this screen in the kit is brand new, and this screen here is probably the original. And it doesn't look dirty, but I'm going to change it. So there's the old one. And here's a brand new one. And you need like a small punch, a round-ended punch, and you can push this in. It's shaped like a basket, and it sits down into this pocket. Okay, so that's in there. Yeah, okay. And then I always rebuild wet. And if you have a question about that, you can watch some of my other videos. I have a vintage Stihl 050 chainsaw video, and I believe it's part 2, where I've got the carburetor going back together, and I have a bench test where I demonstrate the reason why I bench test wet, or I assemble wet. Now, if your piece of power equipment has a purge bulb primer, then you probably could assemble dry, and your purge bulb would draw all the air out of the carburetor and put fuel in here and wet all the gaskets and diaphragms. That would be a circumstance where maybe you wouldn't need to rebuild wet, but I do it regardless. And what that does is it makes the pump flaps. There's 2 pump flaps, check valves, one-way valves, and when they're wet they seal 100%, and when this pump cover gasket is wet, it allows for the crush ribs on the pump cover to more easily bite into the gasket and seal the gasket. You'll notice that the old gasket has these indentations around every chamber, and those are the crush ribs on the pump cover biting into the gasket and sealing it. And that's another thing that I caught Speedy doing one time. He was overhauling a Walbro carburetor off of an Echo PB580 backpack blower, and it had a WTA 33, I think. And he had done one of his Speedy carburetor overhauls with the sonic cleaner, and for whatever reason he would not kit the carburetor after he cleaned it. He would try to reuse the old parts. And so what had happened was he put it back together and he connected the leak detector, and it leaked like crazy. It leaked around the pump cover, and it would not hold any pressure at all. You pump it up to 7 pounds and it would bubble right down to 0 in about 2 seconds. And he asked me, what's going on here? And I questioned him about it, and it turned out that he had lost the pump cover gasket that came out of the carburetor, and he had gotten another carburetor, a WTA carburetor that was similar, and he had taken a used gasket out of a different carburetor and he had put it in his carburetor. And these crush ribs that are in the pump cover, cast in the pump cover, they're like a fingerprint. No 2 fingerprints are the same. And once the crush rib has embedded its pattern into this gasket, it is only acceptable to be used with that pump cover. You can't switch them. Obviously, the preferred way is you don't reuse any of the old gaskets. You get the kit and you put new ones in. They have never been crushed by the pump cover and sealed in that manner. But Speedy, you know, the shops that he worked at before, they probably didn't stock a lot of gasket and diaphragm kits and overhaul kits, and it was common practice for him to take the carburetor apart, sonically clean it, blow it out, put it back together with the old parts. And that's just a big waste of time. You know, you want to renew the parts. So I'm going to tighten this down. And we're going to connect our leak detector. That's one thing I like about a cube style carburetor is that on a cube carburetor, typically the pump is on one side and the metering is on the other side. And that allows you to pressure test the carburetor when it's partially disassembled and you're right here at the critical area. The inlet needle and metering lever, and you can test it. So, but one thing I do want to caution everyone about is the pump diaphragm. Let's see if we can, you know, this is not the perfect example, but this is the wrong diaphragm, but it's an extra one in the kit. If you expose the pump diaphragm to high pressure, as in more than 7 pounds, you get up to 10 pounds and beyond, you're going to start to distort that pump diaphragm. And if you are playing around with pop-off pressure, where you're pumping this up to the point where the needle pops off and releases the pressure, and then you're watching the gauge and its pressure's going down, and then it reseats, and you're recording the pop-off pressure and the reseat pressure, you can damage the pump diaphragm. So pop-off pressure is more concerned with paraglider or go-kart racing or snowmobile racing, high-performance two-cycle, where particularly in a paraglider application, where you know you start out at on ground level and then you're flying your paraglider up to, I don't know how high they get, 5,000 feet or whatever, and you know the pressure changes when you go higher in altitude and lower in altitude. And you know, if you're doing loop-the-loops in your paraglider and you know suddenly there's a flat spot or a dead spot in the engine won't accelerate, well, what if your paraglider you lose control and you go down 4,000 feet and crash into the ground? On a chainsaw, you're not using a lot of part throttle and acceleration like you would be in a racing go-kart or a paraglider or a snowmobile, high-performance snowmobile. This chainsaw is going to idle, and then when you accelerate it and put it in the wood, this throttle is going to be 100% depressed, full speed, full power. So pop-off pressure and reseat pressure is really not very important for lawn and garden equipment. And you don't need to play around with trying to stretch your spring and raise and lower your metering lever and trying to tune out your crappy adjustments by turning your adjustment needles. It's just a chainsaw, okay? So I'm going to pump this up, and we're going to look for leaks, and I'm going to add some fuel and see if there's any bubbles. And with the carburetor partially disassembled, this is very, very visible. Now I've got this up to 1/2 bar, and there are 0 bubbles coming from around that needle. And that would indicate that the needle and seat are in perfect condition. I can let the pressure out by just pressing the lever. And now at this point, what we can do is, instead of relying on your eyesight and dragging the W gauge over there and see if you have a slight drag, you can use your leak detector. So we're going to pump this up to half a bar, and then I'm going to use the W gauge, and I'm going to look for, if I put this on here and we get very, very slow leakage, that's highly accurate. If we get an immediately pressure drop down to zero, very quick, rapid pressure drop, the metering lever is too high. If I put this on here and there is zero pressure drop, then that would mean that the lever is too low. And to adjust it, you bend it up or you bend it down. So let's see what happens here. Okay, the W is right over and the needle is not dropping at all. So that would indicate that the needle is low. So in order to adjust it, I'm going to be bending the lever up. And I want to bend it just a tiny, tiny amount. And we're going to pump this back up to half a bar. And let's see if that adjustment made any difference. Yes. Okay, that's a fairly rapid drop. I'm going to do that again so you can see. So I think I overdid it. And that's how sensitive that adjustment is. So what I'm going to do is I'm going to bend it the other way. You've got to hold the needle against the seat with one screwdriver and then push on the other end. And repeat. That's better. Now we have a slow drop. A slow drop, so that the fulcrum lever is barely touching the Walbro W gauge. And that is a highly accurate way of adjusting your metering lever. So I'm satisfied with, there's no leaks on the pump side. There are no leaks at the needle. My metering lever is adjusted correctly as opposed to this one. That's another thing that Speedy would do. He would, to compensate for old stiff diaphragms that were not responsive, he would raise the metering lever. Now, Speedy didn't work on this one, Einstein did. But when you raise the metering lever too high, you get premature pop-off. And that would make the engine run rich. And in this case, your high speed, you cannot adjust that out with your high speed adjustment screw because it's not adjustable. This is a fixed jet carburetor. There's a number 57 jet in there. You have a certain amount of adjustment at idle. If the mixture is too rich, you can lean the idle. But you can't do a lot. So, the metering lever height has got to be accurate. You do not want premature pop-off. And Speedy was, real guilty of trying to, bend metering levers up, and then he would probably because of premature pop-off, he would try to stretch the metering spring to compensate for it to get delayed pop-off. And, you know, that's probably why they call him Speedy. I never thought of that. It's okay, get your mind out of the gutter, okay? We're going to put this back together. We've got the new gasket here, new diaphragm, and once again, I'm going to be rebuilding wet. These gaskets seal better when they are wet. The diaphragm will soften and be more flexible when it is assembled wet. And I had noted the position of the atmospheric vent hole. And you know, you definitely have to have an unobstructed atmospheric vent hole in your metering diaphragm cover so that atmospheric pressure can enter here and push on this and operate the fulcrum lever and allow fuel into the carburetor. Without that atmospheric vent hole, this won't work. Now, the position that it was in, it was facing outward, and the chainsaw carburetor slightly tilted beyond level. And I don't even know if Einstein knew which way it was on. He might have put it just on backwards. I'm going to put it the other way so that this vent hole is closest to the engine instead of closest to the air cleaner. And that way, sawdust may want to just fall out of it if any sawdust gets in here. So we're going to put it towards the throttle shutter side and away from the choke shutter side. Tighten the screws in a crisscross pattern. And I'm going to have to go answer the phone. I'm going to pause for a second. Come back. Okay, I'm back. That was the Franchise Tax Board inquiring about Speedy. Apparently he's got a court-ordered debt. So, boy, you never know what he's up to. Anyway, I'm going to be reassembling here. And before I get too far, I do want to check to see if there's impulse coming from the impulse passageway here. And there's two ways you can do that. You can, for your do-it-yourself or homeowners who don't have a lot of tools, you can just put a drop of oil over the hole and then pull the rope and see if the oil, blows out or sucks in. And that would indicate that you've got a positive signal from the crankcase. The other way you can do it is if you've got a vacuum pressure tester, you can insert a fitting in here and we'll pull the rope and see if we get a signal. And we do. Okay, so There's always a possibility that the impulse line behind this air box is rotten and leaking. I'm not going to go that far and pressure and vacuum test yet. That would involve removing the muffler and putting a block-off plate over the exhaust port, and then putting an adapter where the carburetor would go, and then putting the spark plug back in here, and then attaching the vacuum and pressure gauge to this carburetor adapter, and vacuum and pressure test the crankcase. So if the saw doesn't run, that would be my next troubleshooting step. Now, what I've noticed, while I got off the phone, I took a look in here, and the fuel line looks like it's out of position. So I'm going to bring the camera in, and we'll take a look at the location of the fuel line. Okay, there's a flat spot on the line. It's kind of hard to see. Maybe it's easier to see here. Okay, there's a flat, and Einstein has definitely installed the fuel line out of position. So I'm going to need to correct that. I don't know if that's a super serious problem, but I've checked in the service manual, and the fuel line is supposed to be located like this, where the flat is parallel with the seam on the tank. So I'm going to be rotating the line and getting it into this position. And I also want to point out one feature on these lines. Some of them actually have a P-trap in them, where there's a low point in the line and it can hold fuel. This one is not quite that way, but it's close. And that's a clever little trick to make the saw faster to restart hot when you've run it out of fuel, if you have this kind of a P-trap design in your fuel line. But the primary purpose of it is so that it will stretch and you can service the fuel filter through this cap opening easier. It'll pull out longer, and then when you let go of it, it has a memory and it returns to that position. The other thing that I'm going to do is the tank vent. Now that tank vent, I'm sure, is original. And what has a tendency for these to happen is the tubing will shrink from age, and then it will collapse around the vent screws, and then you get a restricted tank vent. And this is the early style vent. Stihl doesn't even use this style anymore. So I checked in the service manual here, and you can replace the entire vent and get 2 new screws and a piece of tubing, but I'm out of stock on that vent. So what I'm going to do is I'm going to push the screws out of the old vent, and I'm going to cut a piece of tubing, and I'm going to insert the screws as it shows here in the service manual. And then I'm going to be putting a new vent on there. Talking about the tubing, Stihl makes quite a variety of tubing. Usually comes in 1 meter or 3 meter lengths. And there's an R1, an R3, and an R5. And some of them come in different diameters. 3.1 ID times 5.7 OD. That's kind of the larger size. So the smaller one, this is an R1, and this is 2.2 millimeter ID, 5.4 millimeter OD. And the one we're looking for actually is this clear line. This is an older style line, and that's the part number. And I'm going to be comparing the length here. And I have my favorite tool for cutting tubing. It's a Knipex 9010185, and it'll cut 4 to 20 millimeter tubing. And what I like about it is that it cuts the tubing very, very square. There's like a V block in there, and it cuts very, very square. So I don't want to make the video longer than it needs to be, so I'm going to edit out all of the nuts and bolts and the reassembly. I've explained what I'm going to do, why I'm going to do it, and then when we come back, hopefully the saw will start and run. We'll see. So I'm going to pause for a minute and do some assembly. Okay, I've got the saw assembled and topped off with fuel. We're going to try to start it and see what happens. Keep your fingers crossed. back in the shop after an unsuccessful test run, and I have reviewed everything that the first two mechanics have done to it and really only found two mistakes. One was the orientation of this fuel line. It was rotated out of position, and I've corrected that now. The second was the metering fulcrum lever in the carburetor was set way too high, and that's now been corrected. And that may have been a result of the mechanic trying to compensate for an engine that is not responding and adjusting. So I'm going to go further now that I'm satisfied with the work that's been done. And the carburetor overhaul was definitely not a waste, because anytime you have a metering diaphragm that is this crinkly, you have to overhaul the carburetor. That's just not going to cut it. So they did not waste a carburetor overhaul on this machine unnecessarily. It needed it. And this carburetor, reminding you, this is no longer available. This is an 025, not an MS250, and this carburetor is NLA, so it has to be repaired. So I am going to set up for a pressure and vacuum test on the crankcase, and at the same time I'm going to look at the piston, which I don't anticipate is going to be an issue. By the way it was running, the high speed, even though I was unable to get a tachometer on it and measure the top RPM, my calibrated ear measured it as pretty damn close, and I'm satisfied with it. MS250s run 14,000 no load top speed. A 025 could be also 14,000. I'm going to guess and say 13.5. I'll look that up later. But the high speed, when this was running, sounded pretty good. It's the idle. The low speed in the transition is very erratic and completely unresponsive to the adjustment. So I printed some pages out of the service manual, and the crankcase pressure and crankcase vacuum test are page 14 through 16. And one of the things it says in the very beginning here, defective oil seals and gaskets or cracks in castings are the usual causes of leaks. Such faults allow supplementary air to enter the engine and upset the air-fuel mixture, which is supposed to be about 14.5 to 1. That's what this carburetor will mix, 14.5 parts air to 1 part gasoline by weight. And the next part I've highlighted. It says, this makes adjustment of the prescribed idle speed difficult, if not impossible. Moreover, the transition from idle speed to part throttle or full throttle is not smooth. So this is sort of the symptoms that we have. So I want to pressure and vacuum test this. Now, to make the video short, I'm going to pause the camera and I'm going to gather up what I need. I've already done a little bit of disassembly here, and then I'm going to resume when I'm ready. So I'm going to pause for a moment. Okay, we are preparing to do a pressure and vacuum test on the crankcase of our 025. And I've gone through my collection of block-off plates, and I've picked the correct one for the intake. It's now in place of the carburetor. It has a fitting on it there to attach the tester. The spark plug has to be tight, and if there's a decompression valve, that has to be deactivated, and we need to seal off the exhaust port before we can test it. But before I seal the exhaust port, we're just going to do a quick cylinder and piston inspection while the muffler's off. And we don't want to waste time trying to repair a chainsaw that's been overheated and has a seized overheated piston, scored piston. Now you can see the rings are in excellent shape. The second ring isn't even all the way worn. It's still got some tooling marks on the face of the ring. And you can see horizontal machining marks in the piston skirt. And this engine has very low hours on it. It's in perfect condition despite being 25 years old. Okay, so we're going to block off the exhaust port. Kind of like a rubber gasket there that I made out of an inner tube. If you don't have, the specialty plates and so forth, you can get an inner tube and make your own and duct tape and bolt the muffler back on. If you're a do-it-yourselfer, you can improvise. So once this is tightened down, the crankcase should be airtight. Okay, so this is my pressure and vacuum tester. It will pressure test if the sleeve is in this position, and it will vacuum test if you pull the sleeve to the other position, and you'll notice that the gauge goes negative and positive, and your zero is sort of in the mid-range there. And what the service manual says is it's got to hold 0.5 bar, half a bar, which is 7 1/4 pounds, and has to remain constant for at least 20 seconds. So we're going to connect. Well, actually, before I connect, we're going to test our pressure tester. You always want to put your thumb over the hose and verify that your tester is sound before you test. And see, that's 10 psi. That's a little higher than what we want to go, but I'm just testing the tester. Then you connect, and we're going to try to get this up to 7 pounds. Okay, I went a little past 7 pounds, and you can see that the needle is rapidly declining back to 0. That's not 20 seconds. That was like 5 seconds. Retest again, same result. We've got a leak. That is not going to pass. Now I'm going to switch this to vacuum, and it's the same thing. It's got to hold the vacuum at half a bar for 20 seconds. This time the needle's going to go the negative direction. And the same thing. The needle's declining back down to 0, and that's nowhere near 20 seconds. This is a fail. Now, what I like to do when I've got a leaker is I like to use, I have a mini regulator in that I can hook my shop air supply to this regulator, and I can adjust the pressure to half a bar, and then I can connect it to the engine and get a constant supply of 7 psi. And that will allow me to take my time and check all areas of the saw without constantly having to pump and pump and pump. So that's what we're going to do here. We're going to connect some shop air, and I'm going to try to listen to where the leak is coming from. I might be able to detect it by just listening. Okay, that's about 10 pounds. Okay, that's about 7 pounds. Okay, I can hear some hissing and bubbling. I can't tell where it's coming from. So I'm going to have to do some more tear down. And there's a number of places where this could be leaking. We definitely want to check the crankshaft seals on both sides. So I'm going to be removing the starter and then the flywheel. And then on this side, I'm going to be removing the sprocket and clutch and oiler gear and exposing the seals. And then using, like soapy water or some 2-cycle fuel and putting it on the seals and looking for bubbles. But there's also an intake boot and an impulse line behind this airbox wall. And those could be faulty also. So I'm going to have to do some tear down. And the video is already too long, so I don't want to make it any longer. I'm going to pause and I'm going to do the tear down off camera and come back when I'm ready. Okay, we've completed our tear down and we've got everything exposed, so I don't have to listen and at different spots in the engine. Everything is exposed, so now I can definitely find the leak. I checked the intake boot and the impulse line, and they appear to be in excellent condition. That impulse line was indeed connected to this fitting. It was not disconnected and loose. So I don't see anything wrong there, but we've got to block those off. So I've got a tapered punch I'm going to put into the end of the impulse line. And I've got a bag of these corks, all different sizes, and they have a hole in the center, and I can put a cork in the intake boot and block that off. And then I'm going to put my fitting in there. And we're just going to repeat the test. Go to pressure. And the same thing. Miserable failure. Okay, so once again, I'm going to use my shop air I can hear some leaking. Okay, I've got a little bit of a leak here and right there, and it's not coming from the seal. It's coming from the seam between the cylinder and the engine pan. Check the flywheel side. Yeah, this is not coming from around the crankshaft and the inner lip of the seal. This is leaking between the engine pan and the bottom of the cylinder. We got a big leak there. It's definitely leaking between the bottom of the cylinder and the engine pan. So it appears as though our crankshaft seals are probably good. Now some mechanics feel that there's a specific order in the preferred method would be to vacuum test first and then pressure test, under the theory that if you're applying pressure to the inside of the engine, some old hardened worn crankshaft seal lips will be forced against the crankshaft and artificially seal it, and then it would pass a vacuum test when it otherwise wouldn't have. And I have not found that to be true. I don't think it makes any difference whether you vacuum test first and pressure test second, or pressure test first and vacuum test second. But what there is some truth to the fact that if you pressure test and it holds, and then you vacuum test and it fails, it's always the crankshaft seals. That's a pretty much of a proven rule. So an engine will pass a pressure test, and if it were to fail the vacuum test, you're going to be replacing your crankshaft seals. So what I have to do with this is I'm going to have to put this in the aqueous pressure washer and remove all of the sawdust and grease, and then I'm going to have to remove the engine out of the case. And this is a clamshell design, so we've got a plastic engine housing and a little short block with a metal pan on the bottom of it, and I'm going to have to remove that pan. Maybe the screws have loosened up, but in any event, the sealant that's between the cylinder base and the engine pan has hardened, deteriorated, decomposed, whatever, and it's not sealing any longer, and that has to be fixed. And that will go a long way. That may be the total fix of the saw, I hope. I've got to fix the air leak first and get it to hold pressure and hold vacuum, and then if the saw runs, we're done. If it doesn't run, we have to look elsewhere, probably back in the carburetor. So I'm going to pause the camera to make the video shorter, and I'm going to do the cleaning off camera. And then when I go to reseal it, I'll bring you back. Okay, I thought I would show you just a couple minutes of the cleaning process. This is an ADF glove box washer. It's manufactured in Ohio. It's about 500 psi, uses hot water and a liquid detergent. And it's all made out of stainless steel. And I'm just going to put the power head in there. All of the block-off plates are still on from the pressure and vacuum testing, so no water is going to enter the inside of the engine, but I can thoroughly clean the outside. Okay, I'll bring you in for just a moment before I take the short block out of the engine housing. This is the after words from the cleaning process, and I can get a better view of everything here. The impulse line and the intake boot indeed are in perfect condition. I've disconnected this ground wire because the block is going to have to come up out of the engine housing. There's 4 screws. 3 of the 4 of them are accessible. This 4th one, I'm going to undo this anti-vibration mount and move the handle either this way or that way to get the 4th screw. And I'll let you know if I find that they were loose. If they were loose, that would definitely explain why this has got a leak. So I'm going to pause to make the video shorter and do some nuts and bolts. Okay, I have removed the engine pan and cleaned all of the old sealant off of the cylinder base. And the screws, all 4 of them, were Hercules tight. So what I've done here is I've taken some 220 grit paper, and I've roughened the pan surface. So I'm hoping that if this surface is rough, the sealant will stick to it better. So this side actually has a groove to hold the sealant. So I've applied it to the flat surface, and on this surface I am going to only put it in the groove. Okay, and got to put the pan on the right way. The oil pump is on this side, so I don't want to put the pan on backwards. And then it has to be maneuvered into the engine housing. It's not going to go in easily. Okay, I think I got it. Okay, so I'm going to do the final tightening by hand. Take a look at the position of the seals. they look good. And like I said, when I took this apart, these 4 screws, they were tight. Try to go into a diagonal crisscross pattern. And I think what I'm going to do is I'm going to look up the torque spec for those. And I'm going to do the rest of the assembly off camera to keep the video short. And then I'm going to pressure and vacuum test before I go all back together. And I have to allow that Durco to cure. This is the stuff that Stihl recommends, and so that's what I'm using. And I'm going to make sure that I let it cure before I run the saw. So I'm going to pause the camera again, and we're going to do some nut and bolts. Okay, I went and looked up the torque specification for these 4 screws, and it's 9.5 Newton meters, and I've got a 1/4 inch drive click type torque wrench. It's a Capri, and the numbers are so small on it, I have to use a magnifying glass to read it, but I've got it set, and I'm going to torque these to the final, check the tightness. And, I tightened it by hand. Let's see if they'll go any more. No. Looks like a little bit more. That one was tight. And so is that. Okay, so my calibrated arm was pretty close. And looking at this, you can see there's not a lot of Durco, squishing out from the seam there, so I didn't overdo it. You can't, underdo it, and you can't overdo it. If you overdo it, you're going to end up with all that Durco inside the engine. This side's going to be harder to see. A little bit back of the oiler gear. But now I'm going to allow that to cure overnight, and I'm going to do all the reassembly. Well, actually, I'm going to pressure and vacuum test it, and I expect it to pass. And then I'll be fully reassembled, and we're going to attempt a test run. So we're going to let it cure overnight. I'll come back. Okay, it's the next morning, and the Durco has cured. And this is the first opportunity that I'm going to take it and retest the pressure and vacuum. So I've got the punch in the impulse line. I've got a cork in the intake boot, and I'm going to connect the fitting. And we're up to about 8 psi, a little over half a bar, and it didn't take very many pumps to get it up there. A dramatic difference from before, and it appears to be holding rock steady. Has to hold for 20 seconds minimum. That's a dramatic difference. I'm wondering if I left this here on the bench and came back to it hours later, it might still be the same reading. It might not have lost anything. So that's probably a full 20 seconds. I'm going to switch to vacuum. that's about 8 psi. And the same thing, that needle is not moving. That's a dramatic difference. Very few pumps to fill the crankcase. The needle is not moving. Same thing, if I left this here on the bench for many hours and came back to it, there'd probably still be a vacuum in the crankcase. So this is a green light to put the saw back together and test run it. So I'm going to edit the nuts and bolts out. We'll come back when we're about to run it. Okay, I'm all back together again, and I'm about to put the bar and chain back on. And one minor detail, the chain catcher, since this is a homeowner type saw, it has a chain catcher that usually breaks off, so that as a substitute they make this to provide for when that does break off. So I probably am going to put this chain catcher on, and the carburetor was way out of adjustment because I was trying to enrich in the mixture and raise the low idle adjustment. So I have restored this to 1 turn. The mixture screw, the low speed, is now set at 1 turn. This one is probably set way too high. I'm going to have to back that off. And you know, my target is 2800 RPM for idle and 13,000 for the high speed no load with the bar and chain. And I think we're ready to try it. So I'm going to go outside, move the camera out there, and keep your fingers crossed. Okay, we're back from a successful test run this time. Saw is much easier to start, and with the settings back to 1 turn open and this turn back down, it runs pretty well. A little over 13,000 top speed, no load, about 2,800 in idle. That's right where we want it. And I hope that you learn something. If you do-it-yourselfers are going to try this, now you know what to do. Or if you take it into the shop, you know what to expect in the way of a proper job with proper tools. And aspiring mechanics, this is what you want to do. And shop owners, you know, if you've got a mechanic like Speedy who's constantly trying to raise his metering lever, and then he's got premature pop-off, and then he's stretching his metering spring, you know, you got to can him, especially if, you know, you get calls from the franchise tax board wanting his wages to be attached for court-ordered debts. So, what can I say? If you like the video, subscribe, and make sure that you watch all my other videos. And I think that's going to conclude for today. I don't know what the next one's going to be. It'll be some other disaster that one of my other idiot mechanics can't fix, and then I'll get stuck doing it. So I'm going to sign off for today. It's the Unknown Mechanic.